All right, let's dive into the invisible blueprints of our digital world, system concepts and architecture. These are the fundamental ideas that connect literally everything, from the phone in your pocket to the massive cloud services we all use every single day. So, let's get into it. This cartoon is actually a perfect way to start. We all have this natural, intuitive sense of what a system is. Doesn't matter if it's actual blocks on the floor or a digital simulation of them. At the end of the day, we're thinking about how individual pieces come together to make, well, a whole thing. I mean, think about it. We throw the word system around all the time. Plumbing systems, solar systems, computer systems. But what does it actually mean in a technical sense? Let's try to pin down a real definition for this word we use so casually. And here it is. The core definition really just boils down to three key parts. You've got a bunch of components, they're linked together, and they're organized in a way that makes us see them as just one unit. It sounds simple, but this idea is incredibly powerful. But here's where it gets really interesting. We tend to think of systems as physical things, right? But the components, and especially the links between them, can be totally conceptual. And we have to make that leap to really understand things like software, data, or even how a business works. This comparison makes it super clear. A plumbing system? Well, its components, the pipes, the faucets, they're physical. And the links connecting them are also physical. But then you look at the solar system. The planets are physical, sure. But the links holding it all together, those are conceptual forces, things like gravity and orbits. Okay, so to understand any complex system, we have to start thinking like an architect. But here's the funny thing. The first step isn't building up, it's actually breaking things down. This process is called decomposition, and it's our #1 tool for managing complexity. We take a big, messy system, break it into smaller subsystems, and then break those down into their basic components. It creates this logical, top-down hierarchy that we can finally get our heads around. This exploded view of a smartphone is just a perfect picture of decomposition in action. You've got the display, the battery, the processor, the camera, all these distinct parts. Different teams can design and build each piece totally separately, and then they're all linked together into the final product. This modular approach is absolutely fundamental to how we build hardware and software today. So if decomposition is the act of taking things apart, architecture is the master plan for putting them back together. It's the blueprint, right? It defines all the relationships and all the rules that make sure those individual parts actually work together as one cohesive system. Now let's apply these ideas to the single most important system architecture of the last few decades, the one you're literally using this very second. We're talking about the client-server model, which is the foundation of the internet as we know it. At its heart, the relationship is really simple. You've got two main roles. The client is a program that asks for something. Just think of your web browser asking for a web page. And the server is the program that provides that service. It's the computer that hosts the web page and sends it back to you. This little back and forth follows 4 basic steps. Your browser, the client, makes a request. The network zips that request over to the server. The server figures out what you want, finds the web page, and then sends a response all the way back across the network to your browser. This simple loop happens billions and billions of times every single day. So this basic client-server setup is what we call a 2-tier architecture. Just one client, one server. Simple. But as systems get more complex, this model starts to creak under the pressure. We need to add more layers. The simplest case is this 2-tier model. Imagine your browser asks a web server for a really basic web page that's just sitting on its hard drive as a file. The server just has to grab that file and send it back. Super straightforward, super simple. But here's the million-dollar question. What if the web page isn't just a static file? What if it's your Amazon shopping cart or your Facebook feed? The web server itself doesn't have that info. It has to turn around and ask another system for it, usually a database. And that brings us to a 3-tier architecture. We add a middle layer. Your browser still talks to the web server, but now the web server acts as a client itself, requesting data from a whole separate database server. This separation of concerns is an absolute game changer for performance and for being able to scale up. All right, let's look at the modern evolution of all these concepts. Cloud computing. You can really think of it as a massive expansion of the client-server model, where the server side is this vast, flexible pool of resources you just access over the internet. The big idea shifts from owning hardware to renting a service. The most common layer, the one you interact with all the time, is software as a service, or SaaS. When you use Google Docs or Office 365, you're using SaaS. The software lives on a server somewhere in the cloud, and you just access it through your browser. You don't have to install or manage a thing.
Okay, one layer down is Platform as a Service, or PaaS. This is for the developers. It's kind of like renting a fully equipped workshop. You get the operating system, the web server, all the programming tools you need to build your own app, but you don't have to worry about the physical machines at all.
And at the most fundamental layer, we have Infrastructure as a Service, or IaaS. Here, you're renting the raw computing infrastructure itself, the virtual servers, the storage, the networking. It's like renting a plot of land that already has all the utilities hooked up. You get total control to build whatever you want from the ground up. But of course, the cloud isn't some magic solution. It's all about trade-offs. The advantages are huge. Lower costs, basically infinite scalability, and super easy collaboration. But the downsides are just as real. You're handing your data over to a third party, you're dependent on them, and you're at risk if they have a major outage.
So we've gone all the way from the basic definition of a system to the globe-spanning cloud architectures that run our modern world. For the last 30 years, the client-server model has been king. So that leaves us with one last really big question. What's next? What's going to be the system architecture that defines the next 30 years of technology?